Welcome to my sessions on digital signal processing. In the last few lectures, we were mostly into digital signal processing using MATLAB tool. So, MATLAB is a very powerful tool where we will get a lot of toolboxes as well as like it's kind of premium tool which will be used in most of the organizations. But many people might be looking for open source tools where they can like import some of the libraries that are available freely and do the processing, right? So one of such tool is like Octave, where you can like write your own. You can run the MATLAB scripts on that as well. But like even though that language wise it looks similar to Python, MATLAB, the drawback is like it might not have all the packages, advanced packages which are there, right? So since it's an open source tool, another alternative is basically a Python, and like here we get most of the tools, and like if you like it's Python has become so popular, and like nowadays the trend of Python uh, more and more attraction from research group and even like academic. So today we will see like how we can plot an analog wave using Python. Okay, so most of the concepts like how regarding the sinusoidal wave I had discussed in the MATLAB sessions. But let me recap quickly on the concepts what I had discussed in the MATLAB sessions. So we know that like sinusoidal wave, like one of the example for the analog wave is sinusoidal wave, and it will be like we will have x-axis and y-axis. In the x-axis it will be independent variable, that time, and in the y-axis we will have sine phi, and where f is the frequency of sinusoidal wave, and like 2 pi is actually repetition interval. And so actually like sinusoidal wave, we also know that this sinusoidal wave is periodic in nature, in the sense like if I plot this sinusoidal wave, it will repeat after a period, right? So period. So like this is one cycle, I'd say, repeats, so on, right? So it will be like we'll have such multiple cycles. So this is sinusoidal wave, and also we should see how we can plot, right? First, in the like in the MATLAB, we had seen like first thing what we usually do is like generating x-axis, that is time axis, right? So t equals to let me plot 2 seconds. Okay, I'll plot waveform for 2 seconds. Then like t starts from 0 and up to 2 seconds. And let me consider frequency of wave as 10 hertz. So if my frequency of wave is 10 hertz, it means that in 1 second I will have 10 clock cycles, right? 10 clock cycles. So here I'm plotting for 2 seconds. Then like when you plot this waveform, you should see 20 such repetition. 1 second we will have 10 repetition of that. 10 cycles, I can say, not clock cycle. 10 cycles. So in the 20 cycles you can observe in 2 seconds, right? So initially, let me generate t, and like see, as I told, whatever the processing you do in any digital computers, right? Any digital computers, you cannot process any analog waveform directly, right? So you need to convert this waveform into digital. First, you need to sample it. Actually, you should sample that waveform. So even though here like this waveform looks like analog waveform in the machine PC machine that I had clearly explained in the MATLAB sessions also. Even though it looks like a continuous waveform, but the data what we store inside the computer is like again discrete wave, digital wave, right? So now here, like I need to generate a T and like let me consider I'm sampling. So according to Nyquist criteria, I need to sample at least twice the frequency, right? So since my frequency is 10 hertz, like at least twice the frequency, but usually we go with thrice or like four times. Let me consider 40 hertz as my sampling. That is Fs. So you need to define Fs as 40, and T is like T starts from 0, and this is a sampling, right? 1 by Fs up to 2 seconds. Up to 2 seconds. This is the T waveform what you generated. So now you have to plot uh, y equals to, and again we need to define the amplitude, that is like from peak to peak. What is the peak to peak? Usually it will be from plus a to minus a. So that a you have to define. So for simplicity, let's consider it as a 1, and y is a into sine of 2 into pi into f into f f into t is what you have defined. So in this way, actually, you have to define the way. Okay. Then we need to plot. So usually in Python, we will be using two prominent libraries. One is NumPy, okay, and another is matplotlib. So NumPy is basically for vector operations. Like here, if you have seen, like I've generated a one-dimensional vector, right? So for defining the t-axis, and that is like that we can generate using NumPy. And even like we need to perform certain mathematical operations, or we need to have some constants like pi. So for all these things, and like even if you see, these are all like these operations on vectors. So for these vector operations, we go for NumPy. And matplotlib is a library which is used. I mean, like here it's more meaningful if I say it as a package library. So we'll have NumPy package and matplotlib package, where here using matplotlib you can actually plot the wave, plot any mathematical. Okay, so let's see how we can do it in Python. So sometimes your matplotlib and NumPy package might not be installed in your Python installation by default. Then you may have to install by opening Anaconda prompt and typing pip install matplotlib. This will install all the libraries of matplotlib. You see already in my PC this is installed, so it's showing requirement already satisfied. So if it is not installed, then you may see that like it's installing a progress bar you may see in this company. And like let me try to install NumPy as well. Pip install num. Here if you see like here also I'm getting message requirement is satisfied because like already I have. So next let's open my Jupyter notebook. So where I will be showing demonstration how we can write any code, I mean Python code, and like we can run our experiment. this is the Anaconda Navigator what I have installed. So from here, I will launch Jupyter Notebook. So I have Jupyter Notebook here. So I will launch. So when I launch this, this will open in Chrome browser. So in the Chrome browser, actually you have to let me create new Python 3 kernel. So this kernel will be created. I mean, see, actually, like if you open like with a lab of Jupyter Notebook, then I think like I mean you can create like it's little different. Like directly this will be launched at the time home page. Okay. So here like we can execute certain codes and like you even you can download your file and save .py all these things. Okay. So now let's see like what we need to do plot a sinusoid. So first we need to import NumPy. Okay. So we have created NumPy and like let me import NumPy library, import NumPy as so this actually like it can be any name. This name can be any. So I can import this as maybe as per your wish, maybe MATLAB. That, but like later point of time you have to use this. But let me take this as like default most literatures mention. So next thing is basically I need to import matplotlib. In that I'm interested only on Python. So I'm right now we are mostly interested in plotting analog way. So I'm mostly interested in Python. So see, this is actually good technique. I mean, if you try to import everything, right? So then, like, if you in later point of time, if you're developing certain application, loading of all this library will take long. And so this is kind of optimization where you can call only the packages which you want, so that like your speed of execution will right. So I mean during product development all these questions will come. I mean you might have seen certain Android application where it will take a lot of time to execution but you don't like such where you want fast response. I mean like it's kind of user experience too. I mean like this also is very important when you want to certain complex task where the latency of execution is very such scenarios you need to take care of like optimization of code. I mean most of the people will be not much interested in optimization, but it's a very important aspect in productivity. Okay. So now I have imported NP and plot now. So next thing is like I need to generate time axis, right? So I need to generate time. So, but before that, let me define my FS. FS I will define. I said that am going. So once FS is defined, next task is basically to define time axis, right? So for time defining time axis, we have np dot arrange, and here I need to mention from where to where 0 to 2 seconds with the step of 1 by fs. This is I mean in MATLAB how we had I mean how we did this step. We started from 0 with the step of 1 by fs till 2 seconds. In this way we usually go for like MATLAB command. But here it is np dot np is a library. Next is amplitude. Amplitude I need to plot. So again I will use np numpy directory np dot sine and of time. But actually time into 2 pi, right? So 2 into pi. I can directly go with 3.14 here. I mean, like we have inbuilt constant also, but let me take like 3.14 because, like, if you see like how the MATLAB we had pi for the pi we had actually like directly defined as right. Here it is not defined as a variable. Let me try capital. Not defined. So I we have some defined variables also. Let me explain that maybe in the coming sessions. But like let me forcefully put it as 3.14. And 2 pi f. F I said like I'll be defining it as 10 hertz. And I will multiply this f here and time. Now we have time and amplitude. Next, we need to plot. For plotting, we need to use plot library and the command is plot again. What I'll be plotting? I'll be plotting amplitude with respect to what? Time. Time, comma, amplitude. I, what is next? I plotted time and I plotted this, but I need to label this, right? So plot dot label. It's title, not initially I need to put title. I'm plotting analog signal example, right? So next is actually I need to put x-axis and y-axis. I need to label it. In any engineering problem, if you do not label x-axis and y-axis, the plot will be meaningless unless you label it. So labeling is very important. So I label it as x label as time and plot dot y label as amplitude. So next is actually once you plot it, you need to show this as a figure. For that, show. Okay, plot dot show. Yes, you need not give any argument. So execute this. So we have some error. What's that? So there is a spelling mistake. It's arrange. Right. So let me execute. Again, we have another. NumPy has uh, again single R. Sorry for the spelling mistake. And we have all spelling mistakes, right? So here, yes. Let me. You can see this sinusoidal wave, right? So it plotted from 0 to 2, and like we should have how many cycles? Since like it's a 2 second, in 1 second we'll have 10 cycles, and it should be 20 cycles, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 18, 20 cycles. Right? So here actually you can do few more extra operations. Okay, so I'll show you another thing. If you want to turn on the grid, okay, so you can do it by doing this. Okay, again you have to plot. Here I'll put. Can you see these X grids are there now comparatively? Like previously grids were not there. Now if you enable that, grids will be there, right? And if you want to change the color, maybe I'll, so here if you see it's a blue color, and like if I want to make it as red color, then I'll make it see y0, and like h line I will make it as red. So see this actually like I'm drawing, so the y line I'm not drawing anything, the x line I'm making it as a red color. Previously there was no color, so now I made red color. Okay, so like you can it's assignment for you. You can explore like how I can change the color of this waveform, and how I can change the color of these text as well. So maybe that is assignment for you, and I'll show you in the next class on these parts. Like I'll be explaining on plotting a discrete signals in Python. During that time I'll show you how we can change the waveform color and even the text color. For now, thanks for watching this video, and like please do subscribe to my channel, and I'm planning to upload many more these kind of videos, and like further like some digital design topics as well. Thank you. Thanks a lot. We'll meet in the next.